Welcome back to our introduction to material science. In our previous lecture, we discussed the basic of material science and why it is important. Today, we will dig deeper into the properties of materials. Every material has unique properties that determine its behavior under various conditions. These properties can be divided into two main categories, the physical and mechanical. Physical properties refer to how a material behaves under certain conditions such as temperature or pressure. And one important physical property is thermal conductivity. This property describes how well a material conducts heat. Materials with high thermal conductivity such as metals are used in applications like heat exchangers and cooking utensils. Materials with low thermal conductivity like ceramics and plastics are used for insulation. Another physical property of materials that is important is the coefficient of thermal expansion. This property describes how a material's dimensions change with temperature. How interesting! Materials with a low coefficient of thermal expansion such as quartz are used in applications like scientific instruments and precision measuring tools, where dimensional stability is critical. Materials with a high coefficient of thermal expansion like metals are used in applications where thermal expansion is desired, such as in the construction of bridges and buildings, where expansion joints are needed to accommodate changes in temperature. Another important physical property is electrical conductivity. This property describes how well a material conducts electricity. Materials with high electrical conductivity such as copper and aluminum are used in electrical wiring and circuitry. Materials with low electrical conductivity like rubber and glass are used as insulators. Electrical properties are a key set of material properties that are important in a wide range of applications from electronics to energy conversion and storage. Electrical conductivity is perhaps the most well-known electrical property and refers to a material's ability to conduct electrical current. Metals are typically highly conductive, which is why they are commonly used in electrical wiring and other electrical components. Other materials such as semiconductors have intermediate levels of conductivity and are important for electronics and computing applications. Dielectric properties are another important aspect of electrical behavior. Now, these properties describe how well a material can store and release electrical charges in response to an electric field. Dielectric materials are used in capacitors, which are used to store and release electrical energy in a controlled manner. Other electrical properties include the piezoelectric effect, which describes how certain materials generate an electrical charge when subjected to a mechanical stress, and the pyroelectric effect, which describes how certain materials generate an electric charge in response to changes in temperature. Understanding the electrical properties is important for developing new technologies in areas such as renewable energy, information technology, and healthcare. By designing and optimizing materials with desired electrical properties, researchers can create more efficient energy storage and conversion devices, improve computing and communication technologies, and develop advanced medical imaging and diagnostic tools. If we look at magnetic fields, magnetic properties are another important set of material properties that have a wide range of applications. Magnetism arises from the alignment of atomic magnetic moment within a material, which can give rise to a phenomena such as ferromagnetism, antiferromagnetism, and paramagnetism. Now, the ferromagnetic materials such as iron, nickel, and cobalt have a strong spontaneous magnetization and are used in many applications including electric motors, transformers, and data storage devices. Anti-ferromagnetic materials have alternating magnetic moments that can cancel out each other, while paramagnetic materials are weakly attracted to magnetic fields. Magnetic properties are also important in medical imaging, where they are used to generate detailed images of the human body. Magnetic resonance imaging, or the MRI, uses strong magnetic fields and radio waves to image tissues within the body, providing valuable diagnostic information. In addition, magnetic materials are used in many electronic and computing applications, including magnetic sensors and memory devices. Understanding magnetic properties is important for developing new technologies and materials that can take advantage of magnetic behavior. Researchers now are working to develop new materials with tailored magnetic properties that could have applications in areas such as energy conversion and storage, quantum computing, and biotechnology. Mechanical properties, on the other hand, describe how a material responds to external forces. Some of the most important ones are: number 1, strength; number 2, ductility; hardness, toughness, fatigue, and also creep. Now, the strength of material describe how well a material can resist deformation and breaking under a load. Materials with high strength, such as steel and titanium, are used in applications where strength is critical, like construction and aerospace. Ductility describes a material's ability to be stretched without breaking. Materials with high ductility, like copper and aluminum, are used in applications where they need to be formed into specific shapes, like wiring and piping. Hardness is a mechanical property that describes a material's resistance to surface indentation and scratching. A harder material is less likely to be scratched or dented than other softer materials. This property is important in determining the material's durability and wear resistance. Hard materials such as diamonds and tungsten carbide are commonly used in cutting tools and wear-resistant coatings. Number 4, toughness. It is a critical mechanical property that determines a material's ability to withstand sudden impact or loads. It is essential for materials used in applications such as construction, automotive, and aerospace, where ability to absorb energy before fracturing it is crucial. Number 5, fatigue. It is a property that describes a material's ability to withstand repeated loading and unloading cycles without failure. This is important considering in applications where the material will be subjected to cyclic stresses, such as in aircraft components or automotive parts. Materials with good fatigue properties have a long lifespan and can withstand high loads without failure. Creep is the tendency of a material to deform slowly under a constant load over time. Now, this property is important to consider in applications where materials are subjected to high temperature and constant stresses, such as in aerospace and power generation industries. Materials with good creep resistance, such as superalloys, are preferred for these applications. Now, understanding these mechanical properties is crucial for selecting materials for structural applications and designing components that can withstand the required loads and stresses. And in conclusion, materials possess unique properties that determine their behavior under various conditions, which can be categorized into physical and mechanical properties. The physical properties describe how a material behaves under certain conditions such as thermal conductivity, electrical conductivity, and dielectric properties. Magnetic properties, on the other hand, describe a material's magnetic behavior, which has a wide range of applications in electronics, medical imaging, and biotechnology. Mechanical properties describe how a material responds to external forces such as strength, ductility, hardness, toughness, fatigue, and creep. Understanding these properties is essential for developing new materials which desired properties for a wide range of application. From construction to healthcare, energy storage and conversion, computing and communication technologies, and advanced medical imaging and diagnostic tools. Thank you for joining me today, and I look forward to exploring more of the fascinating world of material science with you.